Okay, thank you, Matt, and appreciate the introduction. And yeah, happy to be talking about this. A lot of this stems from what we've been doing over time at the Mean Animal Research Center with the germplasm evaluation program. If you guys have attended sessions here before, I know you've seen our GP talks and crossbreed EPDs, and just hoping to kind of give you an idea of what else comes out of that, what we're really targeting. That's more than just that annual update to try to make sure that we're covering phenotypic complexes really well and hope to get that transmitted to you and what we hope to do in the future. So I'll talk about that a little bit. For those of you that aren't aware, the US Mark GP program is a longstanding resource that looks at differences between US cattle breeds, and we get our yearly across breed EPD adjustment factors from that. Um, Basically gives current differences then for growth and carcass traits, the traits that almost every breed has right now, to try to allow producers, commercial producers primarily, to put the bulls that they're interested in buying on an equal scale, accounting for breed differences and differences in EPDs from the different genetic service providers that they might be using. But there are a lot of other traits that are biologically relevant that are well beyond just growth and carcass traits that we really need to be thinking about as an industry and need to be giving tools in a way that we can get those out there so that people understand where are some economic profit centers that we don't even have EPDs for in many cases, some of these we do, but not all of them. And where can we kind of maybe make some improvement to help people make decisions? And hopefully we continue to build that list from what I'm showing here. But so the objectives of this talk then are to review the program just a little bit. I don't want to spend much time on that because, like I said, a lot of you, if you've attended these sessions before, have heard about the GP program. I want to share results from relatively recent analyses for some of these novel traits and share project analyses and plans for the future and what we're trying to do to accommodate new traits, maybe more release of these novel traits, and get even predictions back to producers that way. And what are some of the updates that we're trying to handle with tougher issues like how will these EPDs work in different environments? And that, as you know, with genetic bioenvironment interactions, is something we've all talked about a long time, but we haven't all addressed necessarily very well. Maybe we can get some ways with a good resource now to do that better. And I'll talk about some of what we're doing in that area. So most of these results stem from the newer GPE structure. If you guys have or at least as long in the tooth as me or more, you remember talks by Dr. Larry Cundiff, I'm sure, where he'd be talking about cycles of GPE. And originally it was looking at novel germplasm coming into the United States or that might be used in the United States and comparing those to a Hereford Angus base to get an idea of breed differences. Well, since about 2006, we've changed the program. This was an impetus by Dr. Mark Tallman, who really headed up. Let's think about a way to get this program redeveloped so that we're utilizing everything in the program and evaluating from the industry context that he had made and those others of us had made. What are the important things? And it got to be, it's more important to find out what differences we have in the breeds that we have already, more than what are the novel germplasm breeds that are coming on board. So we'll talk a little bit about some implications of that here coming up, but that's what this program is. And it's a continual cross, a continual diallele type of cross. If you're in genetics, where we're crossing purebreds and crossbreds dams from 18 different breeds. These are the 18 different breeds in the US that contribute most to the germplasm. And basically being able to estimate breed effects and heterosis constantly, but from bringing in crosses of those breeds and keeping them as cows or as steers, to continue to evaluate things like maternal effects, maternal heterosis, breed specific heterosis we're getting to now. We had some prototypes with that with Matt's group, probably about just under 10 years ago, and trying to get a good idea of what we can do in that area as well. So we allocate around 3,500 head of our total cows on center at the US Meat Outreach Center to this project. So it's pretty big. Um, as a geneticist, that's not nearly enough data. Those of you that are in physiology or nutrition are laughing at me, I know right now, but we could always use a little bit more to do these things better. But that's why this multi-year project's important. And just an idea, this is the sires that have been sampled from each of those breeds. We sample from each breed. We started out doing it pretty equally, but since as have penetrated the breed, we've tried to keep it where the breeds that are higher in registrations, we're making sure we get the diversity of those animals really well. And this is what we've sampled since 2006 for that. And as a review on what I just said here, we release a table of adjustment factors every year. Usually this is on the BAF website. I need to look where it's at a little bit better right now because I was looking this morning and it's not exactly as easy to find. I'll have to talk to Bob here sometime, but and then we make sure also in addition to these factors that get added to EPDs, we release current breed of sire means these differences between these are as though you use one sire to a common set of cows. What kind of breed differences would you expect? It'd be half of the actual breed difference. So that's an important note here that if you really want to know what the breed differences are, you'd have to take the differences between these and double it. Okay, sort of like an EPD to an EBV. This is just where some of that gets used, and it just shows why it's important to continue to update our program and why we have this continuous evaluation and keep bringing sires in from the industry over time, because breed differences do change over time. And that was something when the project was first set up that wasn't really thought about because we were just in our infancy on national cattle evaluation, but we've known this for a long time that just because you were the biggest breed in 1970 doesn't mean you're the biggest breed in 2023, right? And you can see a huge re-rankings of breeds here. And I'll talk a little bit about this, but an important note, right, is Angus is now the largest breed in terms of yearling weight, and carcass weight goes along with this as well. What does that mean, and what are some things about that we can find out where our other changes that have happened over time. Marbling score is another example of that, and an important note about this is partly that the composition of that gain for yearling weight and carcass weight that we saw isn't the same for every breed, because some have put on greater amounts of fat with marbling, and quality potentially British breeds were already higher to start with, but that's certainly been important, and it's gotten us where we are in our industry today with marbling. But it also means that it has implications for how much feed it takes because of taking a little bit more energy to put on that fat. And I'll talk about that later too. But again, those carcass and growth traits are just a small component of what we try to measure. We don't always get these done on every single animal that is on center, but we try to measure as many traits as we possibly can under several different trait complexes. And what's important here is that even though you see those standard EPD traits, there's a lot of these things in here that we still don't have EPDs for on national cattle evaluation, and our breed differences give us a good idea of where some of the economic merit might be of trying to chase down some of these traits, and where some advantages might be in terms of breed differences. So try to evaluate as many of these as economically possible. So that's kind of the background on all of this. If we look at breed differences then for novel traits, let's think about what have been reported recently. And I could say full stop that we'd rather have more released even than we do right now, but it's important that we have some. And a lot of this work's been done in combination with several students. Some of whom might even be in the room right now, but some that have worked with us and tried to get some of these prototypes done so that we can learn more about some of these novel traits. And I'll talk a little bit about a few complexes that I would note here that I think are important and people have either seen a little bit of or haven't seen very much, depending on the trait complex. And then generally these summaries are analyzed with a similar model to what we use for crossbreed EPDs, an animal model. We're trying to estimate breed effects, heterosis accounted for, all of those things at the same time. Basically a large multi-breed model. And when we've had EPDs to adjust for, we adjust for EPDs, but a lot of these, as I said, are not EPD traits or weren't at the time that they were published. So I'll kind of introduce the topic of each one as I go through them. What I get wrong here, we've got Dr. Andy King in the audience actually, and he'll be talking tomorrow here. He's one of our meat science colleagues that we work with a lot. He did a project on retail shelf life, retail case shelf life, and a lot of this relates to color stability as a biological trait that really reflects how long those meats stay in the case in a way that consumers are preferring, the way that meat looks still. And longer stability leads to less discounting and more product and less product wastage or just, those deep cuts we see in the supermarket when something's got to go, right? Just some references from Texas A&M. The way this is scaled is on a color scale, looking at a few different things. One is hue, which are kind of the colors that we think of. And hue is really measured by three axes. If those of you have messed with computer graphics a little bit, you see sometimes you can pick out a color and change 3 different levels of it. That's essentially what this L star, A star, B star is. It's looking at, what if you change some of those colors just a little bit. I don't remember which is which, and Andy can correct me a little bit on this, but I remember one is like how much black and how much white, and I think one might be green and yellow or something to that effect. I'm not sure I'm exactly right on that. Andy will tell me where I'm wrong. But the point is, these are places where you could get at each of these colors and what they are. And the important thing is kind of the strength of this color, or the chroma, is what decreases over time as that meat would, say, oxidize and really, like it says this here, it will change over with oxidation from myoglobin, which we're used to seeing, to a metmyoglobin, which is going to increase over time as the meat oxidizes. And that's where we get the lost in color stability, where we lose the chroma, which is that intensity I mentioned before, and where we're just getting a lighter hue or a less desirable hue overall on those changes on those 3 axes. And so what I show in this summary really then across the seven large breeds, this used some of the new data, and cycle 7 data is where we had a lot of data on these. So it's kind of the 7 breeds that have the most registration, because that's where our preponderance of data was at the time. And what you'll see here for all 3 of these traits, that color intensity with chroma, the composite color decrease, which is kind of a function of the change in that L star, A star, B star, and then increase, that should say metmyoglobin. My apologies, they're not myoglobin, but this is kind of the increase in metmyoglobin. You can think about it as a decrease in myoglobin at the same time. And across all these, we do see breed differences here, where Charolais and Limousin actually seem to hold up a little longer on this work with color stability than what some of the other breeds do. And so this is a case where we don't have a place where producers are getting paid for this right now, but what should we be looking at, and how should we be changing things to make sure we continue to get consumer acceptance, and where we're decreasing our wastage on the retail level. You can imagine this is a place where if retailers could pay for it, they might be trying to actually put a bit of a premium on something like this. This is one all of us in the room, I think, are a little more used to. There's been a whole lot more feed intake and test gain, but we've had a big extensive program in this since the early 2000s. So this was an early summary that we did on our intake and test gains. Some of this data even went into our BIF guidelines a little bit for trying to establish what needs to be done for intake and gain and so forth. Several breeds do now offer EPDs for functions of intake and gain, whether that's residual average daily gain or direct intake, or as we talked about earlier in sessions today, those things could all be derived using selection index approaches and get equivalency with that. The important thing we thought was try to report the intake and gain differences between these breeds. And these are based on measurements when animals were kind of in their yearling age ranges, if you will, and reported as average daily gain for the test period only. We've done some work since then that Mark Tallman and I kind of worked on together quite a bit. Mark did some really innovative analyses with this, trying to show that you could do a lot of decoupling and look at gains outside of this test period. And that's something DIF now recommends, actually, is actually looking at gains outside just the test period to try to get functions of that finishing gain. So these are some results on that, and as you can see, all of these are compared to Angus right now as a base right now, and the deviations from there. And what you'll notice for both steers and heifers, where steers are fed concentrate diets in this case, and heifers are fed growing diets, basically for roughage for development of heifers. What you'll notice is in each case, Angus are gaining the most, which lines up with that yearling weight slide I showed earlier, right? They're also eating the most. And some of that again goes with that composition of gain right now. And this all comes down to value propositions and where your feed is and what kind of gains you're getting out of it. But as you look down that chart, you'll see that there's a lot of different cases here where there's some animals, breeds that do pretty well. For instance, you look at the average daily gain intake on steers for something like Limousine, and the average intake difference between the two, and you'll see that Limousine are eating less and doing pretty well on gain for this on test period. If those of you that have thought about genetics, this isn't a surprise with the preponderance of the myostatin gene in Limousine with F94L, and you can see efficiency gains with that amount of lean that's being put on that. But it's an important distinction on places where premiums can be gained, and this gives an idea where some of the places that, as we spoke about terminal crosses, that hasn't always been a popular concept. It's a place that people can take advantage of in their commercial operations to try to get an idea of where could I get some things that I don't necessarily have in my cow herd that I want to try to get in my steers that I'm selling for finish later. This next slide on the efficiency just kind of quantifies that into two different indices. The first one is an index that's meant to reflect gain to feed ratio, and you can see as you get more positive in these indices, you get some advantages with some of those breeds I pointed out before here on steers and heifers. You even see a little bit of sexual dimorphism in some of these cases where you have a breed like South Devon here, although we had a little bit less data for them than the other breeds because they were fairly new in the program. They seem to show some advantage on the heifer side with growing with efficiencies on roughage that maybe they don't have some of the same advantages if you look at them on the steer side. So another place where we've looked at this has been mature weight and body condition score, and tried to compare what we get on mature weights in our cattle and where some breed differences might be with that as well. Just some background on this a little bit. We typically measure our mature weights 3 times a year on our cattle right now at a slightly pre-parturition breeding, basically when we're trying to sort up into breeding groups, and then of course palpation, which almost everybody's doing at the same time. And the nice thing about this is, I mean, we can really quantify what the changes have been in mature weight over time. We're sampling the industry, as most of you all, really well, and mature weights aren't what they used to be, right? If people were talking about a nice 1,200 pound cow in some of our pictures last night, I think we saw a little bit about that. We don't have a nice 1,200 pound cow very often anymore. And that's not something everybody always knows, because not everybody weighs their cows, but it's something that's changed a lot with our selection for growth. Nothing good or bad, but these are things that lend to maintenance requirements in our cows at the same time as we're receiving that growth in those animals. So this is some of our results from that, and you've got three columns here. We've got mature weight, and we've got a condition score adjusted mature weight, something we get asked about a lot. That did you adjust for the fatness of your animals for when you reported your mature weight differences? So you could think about that as being adjusted for fat. And then we've got differences in body condition score here. And what's interesting here, you see actually that there's a lot of tightness in the breeds actually. That although some breeds are definitely bigger than others, there's not. If you look at the standard errors on the sides, a lot of them are pretty darn close and within standard errors of being different from each other. So we've got a lot of big cows overall here. The breed that stands out as smallest is Bronvi. If you look at that, adjusted for condition or not. And if people are around that, I don't think that's too much of a surprise around Bronvies with this. There's a few outliers if you look at adjusted for condition mature weight here. And you can see, I'm trying to squint and see myself as my older vision's not getting as well as it is, but you see a few breeds here that have a definitely smaller, larger mature weight or smaller mature weight adjustment if you would account for them not having as much condition or having more fat in their condition, if you adjust them to the same body condition of, so think this targeted around 6, a body condition score of 6 or somewhere around there, Matt, something like that. So from 5, it was 5. Okay. Yeah. Our average might have been closer to 6, and that's probably what I'm thinking of more. So this is really interesting, and this particular set of work is being used in some of the mature weight derivations as a preliminary breed difference. I think it's being used in IGS, or at least prototyped in IGS, to try to get into their evaluation right now as some places where there are sources of mature weight differences, since that there's a real dearth of that data and seed stock to be reported for evaluations right now. So I'm going to close on the traits that we're reviewing with cow lifetime productivity. This was some work by Dr. Warren Snelling, who's also here right now, if you wanted to talk about it a little bit more. But he did a different spin on overall longevity, looking at random regressions over time of cow weight and of cumulative weaning weight of the cow's calf over time. So basically how it's a stayability like trait, but it's basically if a cow is able to stay longer in the herd, she's going to have a cumulative higher weight weaned, right? And if we can predict the genetic aspect of that, we could select for animals and account for censoring where cows have to leave the herd, maybe for reasons that are not necessarily genetic or not related to problems with the cow cumulative or calf cumulative weight. And what he reported on this isn't necessarily breed differences, but he showed kind of an idea of what some of our breeds might look like if you look at contribution of breeds across that 2x2 4 quadrant area where you have higher cumulative weight on one axis and higher mature weight on one axis and higher cumulative weight on the other axis. And I don't expect you to be able to pull apart these dots and say which ones have a predominance of dots in any of these necessarily, but just to summarize it a little bit, in the axis on the left, Angus, Hereford, Brondy, Red Angus, and Shorthorn were overrepresented in the low cow weight and low cumulative weight group. That's WTW is kind of total weight weaned, and CW is cow weight. The next one, Angus, Simmental, Gilvey, Limousine, and Terate were overrepresented in the low cow weight, high total weight weaned, right? So that's kind of the area where you might be targeting if you think about total energy and a total productivity. Those are breeds that are represented in that area. This is a place where this is the kind of low on both, or this is higher cow weight, lower total weight wean. So that'd be upper or over to the right there from that side, Hereford, Brahman, Shorthorn, Anjou, and Solaire. And then over to the right from here, Charlet and Simmental were overrepresented where both traits are high. Okay, what's that mean here? Well, it means that there's a little bit more of those breeds in each of those quadrants, obviously. But the important thing is, as you see from the color pattern, there's a lot of animals from each breed in each of those quadrants. And so there's a lot of opportunity for selection if we were to go down this road for productivity. I know there's several measures of cow productivity in our genetic evaluation systems right now. This is an idea for one that could get maybe a combination of things at once that we could select on. And this could also be used to parameterize the importance of some of those if we get the breed differences out of that for different breeds. So that's kind of a look at where our traits are and some of our current looks. We've got several more that we need to summarize. I'll talk about that here in a minute. The program BIF is offering right now, iGenDec, the selection index derivation program that we've talked about over the last number of years, is actually using this body of work for the selection indices and the differences in the breeds in those selection indices right now. And that's updating annually. So anytime we get results that we put out, we can put it right into iGenDec and account for it right away. And that's an important take-home factor for those people that are interested in using that system. As I said earlier, several of these are factoring into the IGS system as well. We're working on solutions for updating these estimates more often. Mark Tolman had been putting a lot of time into a package that will help us turnkey several of these analysis and hopefully start to get some more, maybe not annually, but more regular updates on some of these trait complexes so that we can report these things a little bit better and a little bit more often. And we're also looking to release EPDs for the sample bulls here. And so what I mean by that is I showed you, we've sampled over 1,000 bulls for the program. We're developing EPDs for a lot of these novel traits and wanting to return these to the producers and to the public, really, if they approve them for release, which most producers have, so that we get an idea of some of the tools and some of the differences that are available within breed as well for some of these traits. This is not going to be a super high accuracy breed. We're talking about progeny numbers in the range of 15 to 20 that we generally produce here. So it's not like we're getting a 10,000 progeny test here, but we are getting some places where we can see some differences on some of these traits that are a lot more expensive to measure and give an idea for where we can help the producers that are contributing to our GPE project. I get asked a little bit about what other breeds can we put into this as well, and what the GPO program is. And this is something we've been thinking about quite a lot lately about what breeds would enter in and be logical here. One of those might be Wagyu. We get asked about quite a lot. Some of the double muscle breeds, particularly Piedmontese, has asked about this and the impacts they're starting to make right now. And all of these are legitimate places where we should get some more data. We had a little bit slower AI season right now, so we're probably not quite ready for the next couple of years because we've got to use some of the semen we have and finish that objective of getting EPDs out to some of these sample bulls. But what we hope in the future to think about what else should we be looking at for other breeds that could make a real genetic merit impact and be compared on some of these complexes as well. There's a few caveats to that. For instance, the two breeds I mentioned, Wagyu and Piedmontese, are both might have some differences in what the optimal way that they're raised in order to get their biggest advantages being shown, as several of you might know, in terms of feeding length, feeding time, maybe even a little bit on the ration for how long they might need to be on that ration to get their desirable benefits. If we're going to continue to do what we do, we may not be able to look at those optimal scenarios for some of those breeds. And that's a realization everybody's got to have with this, that there's management interactions that may help with some of those breed differences. That's something we've seen in the past with old cycles of GPE. So this is more on the EPDs of AI sires for novel traits. And I covered most of this already, but the EPDs that we produce will be multi-breed and genomically enhanced. Last calf crop, our targets right now, our last calf crop was just born this spring that we're targeting with this. So that we'll try to get our first round of this out with anyway. And the first EPDs are expected then late in 2024 when we get most of the data back on those animals. And we really want to look at traits that are not part of cattle evaluations or not covered for most breeds. And some of those are in breeds a little bit, like feed intake and some fertility measures. We'd like to look at things with disease resistance, tenderness, and more of this color stability I mentioned that Andy King led earlier, that I covered. Okay, I want to close just a little bit with the importance of genetics by management, by environment interactions, and we've known a long time that differences in these breeds depend on consistency in the environments for all the EPDs overall, and that if depending on the environment you're in, we might have some re-ranking in sires alone, and definitely for breeds. And some of those advantages we haven't taken advantage of in our system at the Meano Research Center because we're just representing one location. I like to say that even though South Central Nebraska might be the optimum place to live, it's not where everybody's at, and we need to make sure that we look at differences in other part of the country as well. So there's huge amount of data that are required to this, and little has been done to account for differences, and breeds give us a proxy because of the differences in breeds, and re-ranking may be easier to detect than sire differences. And so we took a first stab at this. We're summarizing data now with a project called the ARS Beef Grant Challenge. And what this was taking stockers from the Meano Research Center, so steers and heifers that were going to be finished, and basically backgrounding them in different systems, winter range at Fort Keogh up in Miles City, Montana, short grass prairie, the kind of tall short grass prairie this year with the rain in Colorado, but in that Colorado location, mid grass prairies in western Oklahoma, and then wheat development in El Reno, Oklahoma, as well as our standard calf fed backgrounding system and pins at the Meano Research Center. And we're looking at interactions of some breeds. We highlighted Hereford, Angus, Simmental, and Charolais as for the bigger breeds for that, and look at the interactions in those stocker programs for which ones might be more advantageous under those programs in those different climates and different management systems that are representative of those locations. But that's just stockers, right? And if everybody talks about interactions and breed interactions, what are we really worried about the most? A lot of what we're worried about is cows out on those pastures, right? And what can we find out about what they're eating, and when they have to graze and can only pick up a bite of grass every quarter mile, that's not quite the same as Southwest United States, right? And quality of grass and everything else factors into this as well. So we're looking at our next steps of trying to see what we can do for interactions on cows, and maybe do a better job of picking things up even on the cows and the offspring that might come from those programs. So we've been working and getting our cow herd and GPE to other locations. Right now we're working with Milt Thomas, since he's been down at Beeville, the Texas A&M station at Beeville, Texas, and El Reno, Oklahoma, who was our partner in the Grand Challenge and has an ARS station at El Reno, Oklahoma. And we sent 120 females and 7 bulls down to Beeville very early this year, and sent 69 females and 4 bulls to El Reno as well. And we're hoping then to keep kind of growing those herds and getting ideas of what some of our cow breed differences, cow productivity differences are on the systems that are representative of those 2 locations. We want to keep looking, and we're open to other possible collaborations or other ways to tie it together. We've got some natural ties that we're doing with UNL right now, and want to increase that a little bit, but they're pretty close to us, of course. What can we do maybe with that Miles City location on their females? What could we even do up here in Canada if we can get it accomplished? And how could we do that the best? This is just a representative shot of our cows down at Beeville right now. Some shots Milt's provided to us, and we'd really like to see. We did notice some of our Taurus cattle might be in the shade just a little bit at Beeville for some reason, with the 100-degree temperatures they've had right now. So this is probably some of the most striking contrast we can get, and we're really hoping to pick up something from this. El Reno, Oklahoma. We actually I told Josh White, Mark and I got certified, actually BQA certified for transport this year because we drove the bulls down in a trailer and took them to El Reno earlier this spring and got to come and take pictures and talk to the location leaders and the staff there about treatment of these animals and what we're looking for trying to make sure we have a well-designed project. But those animals look pretty darn good that have been shipped down there a little bit earlier. And we're really happy with the progress both places are already making. So we hope to keep growing this. Again, this will take time to get some numbers up, but we should, we hope really to start seeing some breed contrast that show us something relatively soon. Future traits and what do we need to be thinking about? And some of this we have a lot of data already collected on here. Sustainability, what's that mean? We've been talking about one meaning of sustainability, I think this morning at our sessions with methane production, but that's certainly not everything. And we could talk about environmental impacts and go well beyond methane if we want to talk things like nitrogen and other parts that really just aren't hot right now, but that could be just as important for our future and consumers and everything else if we start paying attention to it. Tenderness, we've already have a preliminary report with this when had some people work on it. Carrie White, I'm not sure she's here right now, did a preliminary look at this, and we've added a lot of data since then and try to get some of those differences out a little bit better. Heifer fertility and cow fertility is a real priority to get out for us, and we've got some prototype data sets ready for that. It's a little more complicated because of the bivariate nature of the trait. And then continuing to look at disease resistance and aspects of disease tolerance. We're developing new programs in inflammation that might give us an idea of which animals are likely to overreact when they get sick. Calving east, calving difficulty. We did have a prototype report for this a few years ago working with UNL, but that needs to be updated. And we have some initial reports we used with our own within bull heifer calf selections this year that we'd like to continue to develop that model and get that out soon. And hopefully then we can get those into that pipeline to get these out a little bit more often. I want to acknowledge our cattle operations crew, several collaborators, Matt being one of those with a whole lot of students. And we've had a lot of work with KSU on this as well, where you probably saw Kelly Ratelik as a graduate student working on the intake. The whole iGendec team, a lot of good U.S. Mark scientific collaborators like Andy King and every breed and producer that's helped us put the GPU program together. Thanks. Take any questions.